Welcome back, architects. Today we are rolling up our sleeves to build, configure, and integrate Model Context Protocol servers. We will go beyond the basics and master the fast MCP Python SDK. Let's kick off with the foundation of MCP server integrations. While our previous sessions discussed MCP's conceptual architecture, today we are building one. To do this efficiently, we leverage the fast MCP Python SDK. Why is this SDK so critical? Because manually writing JSON schemas for every tool and managing the raw protocol handshakes is a massive, error-prone engineering burden. FastMCP abstracts all of that away, letting you focus entirely on your backend Python logic. By simply instantiating a FastMCP object, you create a robust, transport-agnostic server that can communicate over standard input, output, HTTP, or WebSockets. As we dive into the next slides, you will see how this single instance becomes the host for your custom tools, resources, and expert prompts. This architecture diagram illustrates the internal workings of a fast MCP server instance. The central node represents the server object you initialize in your code. Notice how it acts as a router, directing incoming requests to 3 distinct handlers, tools, resources, and prompts. Each handler wraps your native Python functions executing logic, fetching data, or returning templates. At the bottom, the bidirectional connection shows the MCP client interacting with the server. Because the server is transport agnostic, this connection works seamlessly whether your client is running locally over standard I/O or remotely via HTTP. Once you build an MCP server, how does Claude know it exists? That brings us to configuration scoping. The exam heavily tests your understanding of where configurations belong. Project scope servers belong in the .mcp.json file at your repository root. These are committed to version control, so your entire development team automatically gets the exact same tools when they clone the repo. On the other hand, if you are building personal or experimental servers, you register them in your user-level /.claude.json file. Now, let's address a critical security deep dive: secrets management. Since .mcp.json is committed to Git, hard-coding API keys is a catastrophic security vulnerability. You must use environment variable expansion syntax. By writing $curly brace Jira token, you instruct the MCP client to inject the credential securely from the local environment at runtime. This class diagram clearly separates the two configuration scopes you must master. On the left is the project config, representing the .mcp.json file. Note its attributes: it is version controlled, shared across the team, and strictly mandates environment variable expansion for secrets. On the right is the user config, living in your home directory, strictly for local, personal experimentation. Both configurations act as launch manifests for the actual MCP server instances, passing down the necessary commands and securely inherited environment variables. Let's write some code and build an MCP tool. Previously, if you wanted Claude to call a function, you had to write a massive, brittle JSON schema describing every parameter. FastMCP eliminates this entirely through Python decorators and type hints. By simply placing the @mcp.tool decorator above your function, the SDK automatically registers it. How does Claude know what parameters to send? We use Pydantics field class in our function signature. As shown in our sample code, you define docID as a string and provide a description directly in the field argument. FastMCP parses your type hints, your descriptions, and your function name, and automatically compiles them into a flawless JSON schema under the hood. This guarantees schema compliance and makes your backend code incredibly clean and maintainable. Let's trace how your code becomes an API-ready tool. You write a standard Python function. The moment you apply the FastMCP decorator, the SDK intercepts it during server initialization. The internal state machine parses your Python type hints, extracts the descriptions from your Pydantic fields, and dynamically generates a strict JSON schema. This generated schema is then seamlessly passed to the Claude API during the list tools result handshake, completely automating the translation between Python code and LLM specifications. While tools are for taking actions, resources are for fetching data. Think of an MCP resource like a GET endpoint on a REST API. By using the @mcp.resource decorator, you expose data to Claude via URI paths. Why do we use resources instead of tools? Because if Claude just needs to read a database schema or a style guide, making a full LLM tool call is a waste of latency and tokens. Resources allow the client application to fetch the data up front and inject it into the prompt. There are two types: direct resources for static paths, and templated resources that accept parameters like docs//documents/docid. A vital deep dive here is MIME type specification. You must explicitly declare whether the resource returns application/JSON or text/plain. The MCP client uses this MIME type to automatically parse the return payload into the correct format, ensuring your application handles the data safely. This flowchart maps out the resource routing process. When an MCP client sends a read request, the server evaluates the URI type. The top path shows a direct URI request, which maps to a static function returning a broad list of items. The bottom path shows a templated URI. Notice how the SDK automatically extracts the docID variable from the URI string and injects it as a parameter into your Python function to return a specific document. Finally, both paths converge at the formatting node, where the data is serialized perfectly based on the declared MIME type before returning to the client. The third pillar of FastMCP is prompts. What are they? They are pre-built, expertly crafted message templates hosted directly on your MCP server. We register them using the @mcp.prompt decorator. Why host prompts on the server instead of the client? Because users generally write terrible prompts. If you have a highly specialized tool for formatting documents, you want to guarantee Claude receives the exact, battle-tested instructions required to use that tool correctly. How it works is simple. The client requests the prompt by name and provides the necessary arguments. The server dynamically interpolates those arguments into the template and returns a perfectly structured message array ready for the Claude API. The deep dive advantage here is centralized maintenance. If you discover a better prompting technique for your domain, you update it once on the MCP server, and every connected client instantly inherits the improved behavior. Let's follow the execution flow of a server-side prompt. First, the MCP client sends a GET prompt request, asking for the format doc template and passing 123 as the document ID argument. The MCP server receives this, injects the argument into its hard-coded template, and returns a perfectly formatted array of messages. The client then takes this optimized message array and forwards it directly to the Claude API. Because the instructions were expertly crafted on the server, Claude generates an exceptionally accurate output, completely bypassing the user's potentially flawed prompting skills. Building a server is only half the battle. You must test it. To do this, the Python MCP SDK includes a phenomenal tool called the MCP Inspector. What is it? It's a built-in, browser-based debugger for your server. The basics are simple. Instead of running your script normally, you use the command mcp-dev mcp-server.py. This boots up your server alongside a local web interface on port 6277. Why is this so crucial? Because wiring up a full MCP client and Claude API pipeline just to test a single function is incredibly inefficient. With the inspector, you get a clean UI where you can manually select your tools, input test parameters, and execute them instantly. For a deep dive into best practices, use the inspector for isolation testing. Purposefully pass invalid document IDs or bad data formats to ensure your value error handlers catch them correctly. If your error handling is broken in the inspector, it will be broken when Claude tries to use it. This diagram displays the workflow of the MCP inspector. The developer initiates the MCP dev command in the terminal. This launches a development server that orchestrates two components simultaneously, your actual MCP server logic and a web UI hosted on port 6277. The dotted lines represent the testing loop. You interact with the web UI to send test parameters directly into your server logic. The logic processes the request and feeds the raw JSON or error stack traces right back to your browser, allowing for rapid, isolated debugging without writing a single line of client code. Let's tie everything together with a highly practical real-time use case, a document management chatbot. In this scenario, we have a collection of internal project documents stored in our server's memory. Step 1 is standing up our fast MCP server equipped with read document and edit document tools. Step 2, our MCP client application connects to this server and executes list tools, instantly fetching the auto-generated schemas and providing them to Claude. In step 3, the magic happens. The user asks, "What is in report.pdf?" Claude analyzes the schemas, determines it needs context, and issues a tool call. Our client seamlessly routes this request to the MCP server, fetches the text, and returns it to Claude to formulate the final answer. We just built an autonomous agent integrated with custom backend systems with minimal code. Mastering MCP integrations is essential for production architectures. I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Let's walk through this final, comprehensive sequence diagram of our document management system. The user initiates the request. Our application client first polls the fast MCP server for its auto-generated tool schemas, then passes the user's prompt and those schemas to Claude. Claude correctly determines it needs to read the file, emitting a tool use block. The client intercepts this, calls the specific tool on our MCP server, retrieves the raw document string, and feeds it right back to Claude as a tool result. Claude synthesizes this fresh context and delivers a perfect, informed answer to the user. Flawless orchestration.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material. So this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.